Please, can you confirm that you can see my screen?
Yes, Prof.
Yes, yes, we can see it, Prof.
All right, thanks so much. So, welcome to our session on handling missing data. It's going to be a 3-week series, and we'll go into everything about missing data. So the way we've structured it is that we'll look at it from the perspective of prevention, diagnosis, and cure. So today we'll focus mostly on prevention, because we obviously don't want the scenario of medicine after death. So how do we prevent missing values? So we'll understand everything about the challenges with missing values and get a very broad picture today, so that it provides a very solid understanding. Subsequent sessions will assume that you understand at least the theory of what we're going to cover today. So that's the foundation for this series. Next week, we'll talk about the diagnosis. What are some of the statistical tests that we can perform to know the kinds of missing values we're dealing with? Obviously, if you are, for example, for a doctor, you don't just start treating patients, right? You have to diagnose first. You have to know what you're dealing with first. So there are different types of missing values, and there's no one size fits all in terms of treatment. So we'll talk about that next week. And then in the third week, we'll talk about strategies for the cure. How do we now treat it? There are different ways. Obviously, there are wrong ways, and we'll talk about why they're wrong, and then focus on valid ways of addressing missing values. So that's the curriculum for the next 2 weeks. So let's get started. All right, I have a pop quiz for you. What is the most infectious thing in the world? This is when you now answer. Do you have any thoughts? Why are you guys so quiet? Like, Ilungile, please, can you call someone? I don't know.
Viruses, half the truth, bad information, smile, misinformation, smile, laughter, attitudes, not applicable, illiteracy, rumor, not applicable.
Okay. That's a lot of very diverse answers. Well, the most infectious thing. I would like someone to one of the persons who made that answer to unmute themselves and at least defend it. And I'm also surprised nobody mentioned any infectious disease. That's interesting. So does someone want to give us an explanation for why they answered that way? Surely you guys don't expect that I will speak only me for the next. That is not going to happen. So we need a volunteer to explain why they answered that way. And it's not a trick question. What is the most infectious thing in the world? Lungile, no answers, no hands.
Well, it's just on the chat. Yeah, no hands.
Okay,
all right. So it's attitude, flu, missing data, virus, HB virus.
Okay, sounds good. All right, I'll just proceed then.
Okay, there is someone now. Okay, there are some hands now.
All right, I've moved on. Next time. The most infectious thing in the world is missing values, NA, right? NA is the most infectious thing in the world because anything that NA touches or comes in contact with automatically becomes NA. So 1 plus NA is missing values, by the way, depending on however you're structuring it in your software. But I'm going to use NA to represent missing values, henceforth. So anything, like we said, anything that NA touches turns to NA. That's why it's the most infectious thing in the world. So 1 plus NA is NA. 1 minus NA is NA. Any arithmetic operation or any statistical procedure that touches NA turns into NA. So if we're looking for the mean of 1, 2, 4, and NA, well, the answer is NA just because NA is there. So this is why we need to pay attention to this lecture, right? Because NA is the most infectious thing in the whole world, and anything it touches turns into NA. So the question then is, when we're doing analysis and the column has NAs or missing values, what then do we have to do? Well, the answer is obvious. We will then have to remove those NAs. If we don't remove the NAs, well, like we've established, anything that NA touches turns to NA. So our results will, consistently be NA, 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 NA. Obviously, that doesn't make sense. So To address that, when we have a column, and even if you're not aware of it, that's what your software is doing. When you have a column or a variable, what your software is doing behind the scenes is that it is removing those NAs, those missing values, and throwing them away, because that is the only basis upon which it can give you valid results. Otherwise, it will always return NA. So let's look at some examples. This is a random page I just pulled. But what I want us to focus on is this part of the screen here, that this individual is trying to estimate the mean and medians based on R as a software language. Please, can we stop scribbling on the screen? So notice that the command is mean age na.rm equals true. Who can guess what na.rm what it means? Even if you don't program in Python. You know what NA means. What do you think, just from the guess, what do you think the RM stands for? And you can drop your answers on the chat too.
Remove NA, not null, remove,
exactly.
missing.
Exactly. Now, what do you think will happen if you have missing values in that column and you did not specify na.rm equals true, or you said na.rm equals false? What do you think the software will give you? And why? I need somebody to answer that question now, so you can unmute yourself and answer. There are missing values. The scenario is this: you have missing values, but in your great wisdom, you're like, well, I'm going to set na.rm equals false, or I will not specify na.rm equals true. What do you think will happen and why?
Does anyone want to speak?
So, Lungi, the rule is if nobody speaks, you have to speak.
I'll just read.
Okay, that's fine too.
Okay, Miriam.
Hello, my name is Miriam. So to answer the question, for example, when you want to find the mean, and if you don't set whether any is cost true, it's going to calculate the NA values as an object, which is likely to affect your output for the mean. So you always have to set it so that the software would understand it as such.
Thank you. So when you say it's likely going to affect it, how will it affect it? So let's be all very clear on that.
It's not going to give you an accurate result or output.
What will the answer be?
So it's going to increase the total observations you are working with, and hence your mean is likely going to be reduced compared to the true mean.
Okay, thank you very much. Anybody else? We want to really establish this point before we move on, because that forms the foundation for everything else we're discussing.
Okay, Emmanuel.
Okay, if NA is not set, that's if remove NA is set to be true, right? So all the missing values are going to be removed, and so it will affect the mean. While if it's set to be false, it's going to count the missing values as part of the data, and then the denominator that will be used to compute for the mean will be more than it is supposed to be. Therefore, it's going to affect the mean. So in either way, the mean is going to either be skewed to the left or to the right.
Okay, thanks. There's something I'm looking for, which we've established. That maybe let's get somebody else. The third time is the charm. Thanks for your effort.
Mayank.
Hi, my name is Mayank. So if you don't remove NAs, it would make the result NA.
Exactly.
Anything NA touches is NA. Yeah.
And what is the basis for that, based on what we just covered?
Anything NA touches is NA. So
Exactly.
if it tries to compute NA, the result just becomes missing.
Exactly. And so that's the point we're trying to establish here. Remember we said, what is the most infectious thing in the world? NA. Anything NA touches turns into NA. That is why we say that it is the most infectious thing in the world. And this is the reason why your software. Now, obviously, in some software, you have to explicitly state that. Most software, you don't have to state that. They just do it for you automatically. But whether you recognize, whether you are the one putting it or the software is in for you automatically, your job as a researcher is to know what goes on behind the scenes. It's not just that the software just gives you an answer. You need to understand exactly what goes on behind the scenes in whatever software you're using. So all the software, all they're doing is they're going to remove those values and throw them away, because if you leave NA in any column, the result will always be NA. All right, let's look at some software that do not specifically ask you to specify NA. And let's still see how that behavior holds true. So this is Stata. I'm sure for some of you are familiar with that interface. So let's look at, first of all, this point here. This tells you the total number of observations in this data set. And this is, sorry, my vision is just very poor. I just can't see that number. I have to go and change my glasses. Can somebody read out that number for us, please? You know, it's so tiny I can't see it.
1629.
Okay, 1629. Thank you very much. So this number here is the total number of observations in the entire data set, right? All right, now we have two separate procedures here. These are regression analyses that have been performed, right? The first one is just a regression with just the outcome only one variable involved. The second is a regression with two variables involved. So what we want to do is we want to pay attention to see how the sample size involved in each of these two analyses changes compared to what the number we just saw here, which was 1629. All right. So first of all, we have regress against tax, this variable here. Now, the sample size here is 1,537. 1,537 is not the same thing as 1,629. So who can tell us what is happening here? Why has the sample size in terms of number of observations used in analysis suddenly dropped from what we had here to about 100 or so fewer? Who can just explain to us what has happened? What is Stata software doing automatically in the background?
Ibekele.
Thank you, Prof. Basically, what the system did is to eliminate those data points or observation that is missing that variable, the variable of interest or the independent or the dependent variable. So that is what happened.
Thank you very much. Now, let's go to the second analysis. Now, we've added a second variable in the analysis. So it's not just tax 82, it's this variable and this variable. Now, you notice that the sample size has dramatically dropped from 1,537 to 297 here. So what has happened again? What does this 297 number mean? Who can answer that question? What does that number represent?
Jonathan.
Okay, my name is Jonathan from Ghana. So what is happening is so it's a regression analysis to continuous variables. What the 297 means that all the two variables has a sample size of 297, like those they can meet. There are some that have been dropped automatically when you run the regress command. So it means that there are some missing values somewhere. Thank you.
Thank you. That's correct. Who can give us another dimension of looking at that 297? Which other way can we frame that 297? These are individuals who have what?
Moses.
Thank you so much, Prof. I think 297 are individuals that have both tax A2 and those two variables captured.
Exactly. So those are the individuals who have complete data for all the variables. If we added another variable, the sample size might drop from 297 to maybe 150, right? And so it's individuals who have data for all of those variables. So if you're not aware of that, somebody asks you, oh, what's the sample size for analysis? Well, you might be reporting that, oh, my sample size is 1,600, but that is not true. The sample size for that analysis is actually 297, right? But maybe you did not know that because you did not know, or you're not aware that the software automatically just drops values for individuals who have missing data. So this is not just common to data. For any statistical procedure to work, right, there has to be consideration of NA, because anything that NA touches turns to NA. And so we have to find ways of addressing that. And so this becomes very important. This sets a framework for why we have to be very meticulous about how we capture data, so that imagine the effort we went through to capture data for 1,600, only to be left with 297. That is very, very inefficient. So it is very clear that we need to do better when we're collecting data to ensure that we reduce missingness to the least extent possible. And when we have missingness, to also figure out ways we can address them in a way that is valid. So let's look at some of the implications of missing data and why we're concerned about that. So we talk about how we sequentially go from the target population. The target population is the population that provides the sampling frame. From the target population, we go to the sampled population. Then from the sampled population, we go to the analyzed population, right? So in this case, our sampled population was the entire US. That's the US survey. The sampled population was, let's say, the 1,600 and something people that were in the data set, right? Let's just assume that everybody who was sampled provided a response. But the analyzed population, this is where the crux of the matter lies. The analyzed population is not 1,600 people. The analyzed population is actually 197 people, or whatever that number was, right? Now, that has a lot of implications, because now we're generating estimates from 1,600 people, 137 people, even though we had sampled a lot more people. And so we need to consider the potential implication for bias that arises from that, right? Because we had individuals who were included in the survey that are now suddenly excluded because of missing values. So the question then becomes, how similar, or is there a systematic difference between individuals who have been removed because of missingness versus those who have not been removed? So remember, we said that the inclusion criteria sets the perimeter for your study. Individuals who are outside have been excluded based on inclusion criteria. And everybody inside has been included because they meet the inclusion criteria. The exclusion criteria says, well, you guys are inside the cycle, but I'll have to remove you out for whatever reason. In this case, individuals have missing value. So whether you realize it or not, they're being removed from here because they do not meet the criteria for the analysis, which is having complete information. So this is what missingness does to ROD. It allows individuals who had met the inclusion criteria to be systematically removed from the analysis, which begs the question of, are these people in red or in pink, are they different systematically from those in green? If there is a difference between these guys with a question mark and the ones with a check mark, then we have selection bias on our hands, right? So that is why we need to be worried about this. And that's also important from the perspective of generalizability, because we are very familiar with the cycle of inference. From a sample, we get estimates to make an inference to the population, and the population gives us a sample. So imagine that we had the 1,600 individuals and that they were a representative sample of this population. But suddenly we have hundreds of people, if not over 1,000 people, being dropped because of missing values, right? If the people who are remaining in the sample are no longer representative of the population, then we no longer have a cycle of inference, because now we have selection bias on our hands, which blocks this arrow here from the sample to the population. So that means that we can no longer make inferences from sample to the population. Inferences can now only be made from a sample back to the sample. We cannot speak for the population because the sample is no longer representative of the population. So that's the problem with missingness. Now, apart from descriptive analysis, there are also issues that arise with missingness in the context of analytical studies, which are comparative studies. Remember, we talked about internal validity as the extent to which the study is free from threats to validity, including confounding bias, measurement bias, and selection bias. In other words, we hope that the individuals who are exposed are exchangeable to those who are unexposed. In other words, it's like you're looking into a mirror. The person you see in the mirror should be you, right? That's what we mean by exchangeability. The exposed and non-exposed, or the treated and the non-treated, are exchangeable. In other words, they are alike in every other respect except for the treatment or except for the exposure. But in every other thing, they are supposed to be exchangeable. Now, we have a little problem on our hands whereby one group has extensively more missing values than the other. And what that does is that changes the composition of one group relative to the other, right? It's like, okay, initially you were looking at yourself in the mirror and then you found yourself to be exchangeable. Then suddenly there was a blast and then you had extensive injuries so that when you are looking, like a whole section of your body is gone. So now you're looking in the mirror and you're no longer exchangeable with the other guy because of this huge missingness. That's the problem. Now they're no longer comparable, they're no longer exchangeable, and that threatens the whole basis for internal validity, because the whole premise here is that the exposed and non-exposed are exchangeable in every other way except for the treatment. But missingness threatens that such that we have samples that are no longer exchangeable, and so that brings in a lot of bias. It brings in confounding bias because now the distribution of key variables between the exposed and non-exposed is no longer the same, right? And that is a problem for us because we can no longer make valid inferences. There's also obviously the issue of type 2 error. Remember, we've talked about the role of sample size in type 2 error, right? Type 2 error simply means that you have false negatives. The results were not significant in your study just because you had a very small sample size. It should be very obvious how missingness will result in type 2 error. Remember, we've established that when you run your regression, only individuals with complete data are included in the regression. So imagine that you needed a sample size of 600 people in each group to detect the difference. Now, suddenly you have 100 in each group. Obviously, you don't have enough people to detect a relevant difference. So you end up saying that, well, there's no significant difference in the study. Whereas the problem is that you are underpowered. You don't have enough sample size to detect differences. So those are some of the issues that sample size or missingness introduces to us that we have to tackle. So the question then is, how do we tackle it? I saw this message on an academic group, and I was like, oh wow, this is really disturbing, or at least concerning, the viewpoint that we need to just look at it together and look at things to avoid. So the idea here is that, wow, AI is doing very well, and it takes 3 minutes to do data cleaning, checking for missing values, drop NA and fill NA. There's no stress at all. You just click and you are home and dry. I thought that was very funny. So I took a screenshot of it. I'm like, okay, let's discuss that. You are definitely not home and dry. Just clicking on a few buttons and the system just fills in some values for you. You are definitely not home and dry. So we really want to just buttress how dangerous this kind of approach is for handling of missingness. And it's by no means not restricted to that individual alone. You have a plethora of platforms and software that manage data, and they have so many fantastic promises. This one talks about dealing with missing data. It says you can. My eyesight suddenly just became bad overnight. but in the body of the text, they talk about, replacing missing values with, for example, the mean values or the average values. Again, we cannot emphasize enough how dangerous that is, right? And then just to raise our level of consciousness that there's an extremely high amount of bad advice, like just huge amounts of bad statistical advice on the internet. So please be very careful when you go online to search for answers. Just make sure it passes the laugh test, right? So this individual was recommending that, okay, you could replace missing values with things like the mean or the average. That is horrible advice, right? Now let's look at some of the reasons why it doesn't just make any sense to try and apply those kind of approaches to managing missing values. So most of the algorithms, this is what they do. They either drop NA or they fill the values. They fill the values either with forward fill. Forward fill means that you take the response and, so let's look at an example. So we have a mini data set here. This is the index. And here we have columns A and columns B. Here you have individual number 2 has a missing value for column A, right? Individual number 1 has a missing value for column B. So what does drop NA do? Like, if you decide to drop the values, what does that mean exactly? It means that individuals with missing values, which is this scenario here, will be dropped. So in other words, row number 1, individual on row number 1 and on row number 2 are dropped. So our data set reduces from the 4 rows we have to 2. That's what drop NA does. So most of the automated single-click softwares or solutions you run, when they say they're handling missing values for you, that's what they're doing. They're just dropping them and they tell you, oh, you're all fine now. You're home and dry. No, you're not home and dry at all. And we're going to discuss why you're not home and dry. And then you have fill NA. This is forward fill. You can have forward fill or backward fill. So in forward fill here, individual number 2, so we had missing value here, right? And so we're now filling the individual's response with the guy in front of him, the guy forward of him. So just imagine how ridiculous that is. It's like you're standing in line to buy groceries and you realize that, oh, I'm missing money. And you turn to the guy in front of you and say, oh, just give me your money. Like, let me fill my pockets with that. Like how? What's the basis for just grabbing the value in front and just filling it into that missing value? Makes no sense whatsoever. The same thing with backward fill. Backward fill is saying, oh, we're just going to grab the guy who is right behind and just patch it in there. Remember that these individuals who answered row 1 and row 2 are in row 1 or row 2 or row 3 are just completely different. The only reason why they are next to each other is just random chance. So it's just really bad advice to say we're just going to do a forward fill or a backward fill, or worse yet, say we're just going to take the average of that column and just patch everybody who has missing values with the average. Makes no sense whatsoever. So I really just want to emphasize in the strongest language possible that is really bad advice, and you shouldn't just put faith in whatever a software that is telling you, oh, just click here and the missing values will all be gone. So let's look at visually what imputation, again, just the common approach is done, imputation and deletion and what they do visually. So here we have ABCDE or ABCD and missing value. So what imputation does is that it says, okay, I'm just going to guess the value here. I mean, it's a lot of regression, but it's still a guess. And then it fills the value here. So the goal, whether we're deleting or we're adding, is to have a perfect rectangle, right? And so for imputation, we try to have a perfect rectangle by just trying to fill in the value with an educated guess. With deletion, we just remove the ones with missing values like we've established. Now, why is it bad from a scientific perspective? What is the problem scientifically? Well, the problem is that each of these procedures obviously have tons of scientific publications about them, but they each rest on certain assumptions. When you use imputation, the assumption is that the data are missing at random. This is very important. This is one of the most important parts of the lecture. The assumptions that underpin certain procedures. When you're using list-wise deletion, which is just deleting everybody with missing data, the assumption is that data are missing completely at random. Now, that might sound like Latin to you, but we're going to explain what this means so that we are all on the same page. So, on one hand, you need an assumption that data are missing at random. The other is like the data are missing completely at random. The problem, however, lies that in the far vast majority of cases, data are not missing at random or completely at random. Data are missing not at random, right? And again, I'm going to explain what that means. So you have a scenario where most patterns of missingness are MNAR, missing not at random, not MCAR or MAR. But the assumptions for these procedures require that the data are missing at random or not at random. So for us to understand this better, we're going to take a minute to explain what those terms mean so that we understand from first principles what they are. And that will help us understand why those approaches are really, really bad and why we should really avoid them. So there are two fundamental reasons from a philosophical perspective why we can't just say, oh, we're going to do forward fill or backward fill or just take an average and just plot, just plop it everywhere where there's missing value. The first reason is because not all missingness needs treatment, right? You don't want to be the guy with the hammer to whom everything is a nail. And then even for those that need treatment, not all treatments are the same. So those are two fundamental reasons. It's not every time we need treatment. And even when we need treatment, not all treatments are the same. Treatments are, predicated on certain assumptions. And if those assumptions are not met, then the treatment will fail. So I'm a dentist, so of course, tried to make this a dental themed lecture. So let's think about it in the context of tooth loss and how you manage tooth loss. By the way, are there any dentists in the house? No. All right, no. So let's look at it from the perspective of, how that is similar to managing tooth loss. So the question is it every time that you have a missing tooth that you need to fix it? Well, no. Why? Because you may have had some teeth that were removed intentionally. So for example, somebody who had an impacted third molar that was removed intentionally. The person went to the clinic and it was removed to solve a problem, right? The tooth may also have been removed as part of a treatment plan. Maybe the person had overcrowding, and so there was a reason why it was removed. So the bottom line is not every missingness requires treatment, because the missingness may actually have been intentional and not just a bad thing. So there's some missingness that actually are a good thing. Not every missingness is a bad thing. That's the point we're trying to establish. And then back to the dental illustration, even when there is missingness that is not a good thing and we are trying to fix it, not all solutions are the same. We need to evaluate. We look at context. Okay, why is the tooth missing? Is it a front tooth or is it a back tooth? And so many considerations, right? Those clinical considerations now influence our choice. The kind of treatment of missingness you might have for a front tooth that doesn't have a lot of occlusal bite, where you're not biting on heavy things, is quite different from what you would have to do for a tooth at the back where you're chewing things on, right? So we're going to make all of you honorary dentists by the end of the session. So the same way that handling missing teeth requires context, that is the exact same way. So this is no different from handling missing data. The exact same principles apply. That not all missingness requires treatment, because some missingness are actually a good thing. And number two, even when we need treatment, context matters. So, and this is why you cannot rely on AI to manage missing data. AI can do a lot of things, but AI cannot produce context. That is the one thing that AI cannot do. AI cannot tell us the context for why the data are missing. And this is why it is, for this singular reason, this is why we cannot just say, oh, I read that there's this AI software that just handles missing value. Just click and boom, it just corrects the problems. Like that is a bad idea because to handle missing data, you need context. So this is very, very important for us to remember. So now let's go back to those 3 missing values, because next week and in upper week, we're going to be talking about a whole lot of strategies for MNAR, MCAR, and MAR, right? The 3 fundamental types of missingness that we have. So we need to really understand them. Otherwise, the next 3 weeks might not make a lot of sense to us. So I'm going to tell you a story, the story of a man who went missing. So the man just disappeared. His wife was worried, called the cops that, oh, I haven't seen Jim for the past 5 days. So of course the cops came and took a lot of notes. Of course they have the suspects. The first suspect is always the spouse, right? It's like, okay, tell us where you were on these days. So the first suspect was a wife. The next suspect were his neighbors. Well, actually, the first suspect is the guy himself. Let's be clear. The guy himself is like, all right, these are very hard economic times. Anything can happen. So let us collect more information about this guy. Like, what are the circumstances surrounding his just mysterious disappearance? So the guy, first suspect, the next suspect, the wife and the neighbors, right? So we need to understand. So that sets the premise for the discussion. So there are 2 sides of the fence here. On the one side of the fence, we have the guy who is missing, right? The other side of the fence, we have the wife and the neighbors who are the secondary suspects. So primary suspect is the man himself who is missing. The secondary suspect is the wife and the neighbors, right? So we would love to interrogate this guy really, really bad. We would love to ask him questions. Well, there's only one small problem. We can't ask him questions because he's not there. If he were there, we could ask him, hey, where are you? And we'll solve the problem, but he's not there. So he can't speak for himself. So that's the dilemma when we are trying to investigate missing values, right? And we'll talk a little bit about this. It sounds a bit abstract, but it is fundamentally important to how we approach missing values. So here are the rules of engagement. If we can prove that the guy was not involved in his disappearance, then we can say that he's missing at random. However, if there's any evidence that he is somehow implicated, he orchestrated his disappearance, then obviously it's not random anymore. So that's on the side. The same thing applies on the other side. If we can demonstrate that these guys or the guys, the wife and neighbors were involved, well, then it's not random. But if we can demonstrate that they were not involved, then it's random. So that's pretty simple. The rules are simple. So for each side, the question is, are you involved? If it's yes, it's not random. If it's if it's no and you're not involved, then it's random. So that's pretty much. Now, this forms the basis for how we classify missing values, right? So first scenario is when it's random here and random there. There is like, okay, there's compelling evidence that this guy was not involved in this disappearance, right? We know because this guy, he loves life, he loves the community. We think he's a good man. It seems very improbable that he would just orchestrate his own disappearance. Like, why? He was even very wealthy. There was no reason, there was nothing he would benefit from just disappearing. So we say, okay, we don't think this guy is implicated in the disappearance. So we can conclude that it is at random. And then we come to the other side of the fence and we say, okay, these neighbors that we're looking at, that we're observing, there's no evidence really that they orchestrated this, right? And we've interrogated them, we've cross-interrogated them, and their story just adds up. And so we just conclude that they're not implicated. So here we have 2 randoms. Random for the guy who is missing, random for the guys who are observed, right? When you have 2 randoms, it is completely random. And this is when we say that missingness is completely at random. In other words, there is nothing about the question that led to it being missing, right? Think of questions that you might ask like, oh, what is your sexual orientation? Or do you smoke weed? Well, there's something about that question that people might choose to say, oh, I don't want to answer that question, right? But if it's just an ordinary question, like says, for example, what is your age? Please select. There's nothing in that question that would trigger somebody not to answer it, right? So we look at that question and say, well, you see, this question just looks straightforward. There's nothing about it that is sensitive. There's nothing about it that will have led to it, resulting in missingness in of itself, right? If we can conclude that, we can then say that missingness is random on this side. And then we can now say, okay, are the neighbors are the neighboring variables in the data set, right? We now say, okay, is there an association between these neighboring variables and the missingness in column? So we have column A, and we're trying to say, okay, are the values in this column, is the missingness related to columns B, column C, column D? So we might, for example, create a binary indicator from column A, 1 if it's missing, 0 if it's not missing. And we can then do, for example, a bivariate test with columns B, column C, column D. We'll talk more about that in the next week, right? But just giving you a very high-level picture. And then we can see that, oh, wow, there's no association between missingness in column A and column B, or column C, or column D, right? So the neighbors, which is the neighboring variables in the data set, are not associated with missingness. So we've looked at both sides of the fence. On the one side of the fence, there's really no compelling reason to say that this guy had a hand in his disappearance. In other words, there's nothing about that question that could have led to people not answering it. And then there's also no association between the variables in the data set, the other variables, and missingness for that variable. So at this point, we have no choice but conclude that missingness is completely at random, because we have two randoms. Remember, we have two randoms, random on one side of the fence and random on the other side of the fence. Two randoms means completely random. Now, the question is, do you think that MCAR is fully testable statistically? What do you think? So I need somebody to answer to that. Can we, in other words, what I'm saying, the question I'm asking is, can we prove 100% for sure that in our illustration that this guy has no hand in his disappearance? Is it possible to prove that to 100% or absolute certainty? What are your thoughts?
No, yes.
Well, I need somebody to take the mic and explain to us their reasoning.
Please raise your hands. Akua Kilson, please unmute.
Hello? Hello?
We can hear you, yes.
I think you can look at the whole of the data set and see if where you take that variable and you analyze it, you get a significant estimate.
Okay, thank you. Any other perspectives? And I would like you to pursue the lines of our analogy and let us just reason it that way.
Hello?
Yes, go ahead.
Yeah, I think it's impossible because for us to prove, we need the guy himself. And here the guy is missing. So there's no way to authenticate without seeing the guy.
Okay. What of the other side of the fence? Is it possible to interview all the neighbors? Like you
not possible.
Next 4 neighbors, right? Go ahead.
It may not be possible to get all the neighbors to interrogate it too.
How does that align with data capture? The issue that we at any point in time we can only have a finite number of neighbors being interrogated. How does that align with data sets.
Well, the variability also, because we might not get a constant number of neighbors to be interrogated. So that also introduce some variability that affect the data ultimately.
Thank you. Like in your data set, like at max, how many variables could you possibly collect in a survey?
Wow, I think I'm not aware of a particular number of variables.
Yeah.
I think it's as small, as much as as large as the survey is. It depends on how.
Reasonably, what's the maximum number of variables you have collected in a survey from your own experience?
Well, I don't know, but from Stata, I know that Stata gives based on what edition or what model you want. There are some that can collect up to millions, some that can collect up to hundreds. So, because from that knowledge, I think it's possible to get up to millions of variables.
Yeah, but now I'm not interested in Stata. I'm interested in your survey, your data.
Well, I've got something like about 600. No.
Okay, thank you. Okay. The point I'm trying to make is that a survey can only be so long, and you can only collect so much variables, right? A traditional survey may not include over 100 questions, and even that's quite long. Now the problem now is you've captured 100 neighbors. How do you know it's not the 101st neighbor that kidnapped him? You've only interrogated just the 100 you grabbed. And so even if the 100 told you, oh, I'm not guilty, and it's true that they're not guilty, the question always remains, but what about the 200 neighbor or the 1,000 neighbor down the street? We did not include them, right? So the bottom line is that our data capture is always finite. And so even when we're looking at the neighbors, we can never capture all the neighbors. So we can never say that this guy's disappearance was not linked with the neighbors because we did not survey all the neighbors. We only grabbed the wife and the people who were close to him. But it could have been anybody on that street or even the next street, for those reasons, right? MCAR is not fully testable statistically, right? Because we cannot test for every single variable. Is that very clear? If folks, since this is quite sensitive to our next course, if you have questions, you can drop them so that we can clarify that before we leave the context of MCAR. But it's very important that we understand this. Any questions, any thoughts? Does somebody want to rephrase it in their own words, the way they understand it, so that we can really be sure that we're all on the same page?
There's a question. So MCAR is never possible to verify?
Fully verify. Statistically, no. You can never fully verify it.
Omolola, you have a question?
Yeah, thank you so much. So yeah, it's very clear, like just from the perspective of like just going with the story that the guy is missing, so there's no way we can verify that. And then the whatever the particular question is that is missing, like it's just my understanding of what I think the other variables I think are associated. There may be others that are associated that I'm not even thinking about and are not in my survey. So just like the analogy of neighbors or maybe workers or somebody he met in Uber or something that I'm not even thinking about. And then from the statistics end of things, just the idea of statistics is all about uncertainty. Like it's statistics itself is never a guarantee. There's always a level of uncertainty involved in statistics. So both going like from just thinking about it from the idea of the variable itself, the associated variables, then even the statistical test, the fact that there's no foolproof statistical test, I think it's clear
Okay, awesome.
why
Thank
we
you.
can be. Yeah, thank you.
Awesome. Thank you very much. So So, but the bottom line is that when you're using a test like listwise deletion, so when you go to that AI tool that tells you just click here and we're going to address it for you, it is assuming that missingness is MCAR, that there is no association between the neighbors and this guy's disappearance. And there is no way this guy was involved in his disappearance. None. This is the only basis upon which you can use techniques like that. This is a hard, very, very hard, assumption to meet. So this is why you should just, any software telling you that they are just going to do this for you, no, you should just say, no, that makes no sense. All right, let's go to examples of MCAR. Think of a scenario whereby, taking a survey and the server just shut down. This is like a lightning strike. It's completely random. So in this case, we have individuals who have missing values, but so let's say I was answering the questionnaire, I was on question 4, and then the server just cut down and suddenly I did not answer question 5, question 6, or the subsequent questions. Well, there's nothing about questions 5 or question 6 that made them unanswerable, right? The questions themselves had nothing to do with me not answering them. And it was just bad luck. That was just what happened, bad luck. So when the scenario feels like this was just really, really bad luck, just bad timing, then we can say, oh, missingness is likely due to MCAR, right? So that is the whole context here. When the explanation is more, oh man, we had just bad luck. So if it's luck, right, and not people, then we can say, well, it's MCAR. Now let's look at when we have just one random. So remember MCAR, you have random here, random there. Now in MAR, which is missing at random, we only have one random. We can swear this guy was not involved in his disappearance, but the neighbors are very sus, right? There's just some reason to believe these guys were involved in this guy's disappearance. So you have random here, but not random here. This is what we mean by MAR, missing at random, because you have only one random. So we remove the word completely. Completely is when you have two randoms. Random here, random there. If it's random here and not random there, obviously we can't call it completely. So we delete the word completely and we're left with missing at random. So that's what MAR means. So again, the question is MAR fully testable statistically? What do you think? Because this is the basis for multiple imputation. Multiple imputation assumes that the data has met the standard of MAR, that's missing at random. So the question is, can you fully test, can you test MAR fully statistically? If so, why? If not, why? What are your thoughts?
Moses, you can unmute. Okay. Mostly no.
Okay. I want somebody to articulate the reason they're thinking about it. If we don't understand this part, we're not going to understand the whole series. So that's why we just need to make sure we're all on the same page in terms of at least the theoretical framework for it.
So it's the same reason that we discussed before, that there might be some variables that we have missed or just not collected because we didn't know about them. And there might be hidden associations that we haven't considered.
Okay.
So it might not be possible to fully test if even those are missing.
Okay. But on that side, on the neighbor side, we've already said the neighbors are guilty. So whether it's one neighbor or 10 neighbors, we already concluded on that side that the neighbors are guilty. So it's not random on that side. So your argument will have to be on this side. Your argument was on this side.
So without the guy, we cannot test at all.
Exactly. So that's why it makes it hard, right? You can try, but you cannot fully say, well, we have proven that the data is MAR or missing at random, because there's almost always that doubt that, well, what if the guy, sure, the story adds up nicely, but what if he really was involved? We never can tell because the guy is not there to answer for himself. So when we talk about MAR, we're talking more now. It's people involved, right? We're talking about so you've had some cheesy breakup lines like, oh, it's not about you, it's all about me, right? Well, this is what missing at random is involved. It's not about the question. So there's nothing about the question itself that could have triggered people not to answer it. It's more about the people. So when you say, for example, what's your age? Well, objectively, there's nothing triggering about the question age that will make us consider that people will skip age, right? So there's nothing about the question in of itself. But suddenly when we look at the age, we realize that a lot of females had missing values for age than men, right? So in of itself, we cannot say that there's anything about age that will have triggered people not to answer it. But we see gender differences, or we see differences by other constructs in how the answering pattern is, or the response pattern for that question is. So it's not the question's fault, it's the fault of the people. So whenever people are involved, we say, oh, it's MAR. So remember, whenever chance is involved, we say it's missing completely. Whenever people are involved and there are systematic differences, then it shifts more towards missing at random. Now, whenever we have MAR, the question we're trying to answer is everybody equally screwed? If the answer is no, then it means that we're likely dealing with MAR, right? So that is how we look at it. So MCAR has to do with chance, like, oh, some just really bad luck happened and we didn't get our responses. MAR has to do with people, not just chance. Like these people there's something about them that makes them not want to answer that question. Even though that question is fine, there's nothing wrong with that question, but these people just don't like that question for whatever reason. Now, the third type of missingness is not random at all. So in this case, there's no random here and there's no random here. So the neighbors are sus, the guy himself is as sus as hell too, right? And so in this case, there's no random at all. So we say it is not NMAR, missing not at random, right? So it's not random at all. Both sides lack randomness. So in this case, for example, the guy could have told the neighbors that just kidnap me and then we'll share the reward later. So both of them are implicated. The guy is implicated and the neighbors are implicated too. In data, this will be when there is something about that question that makes people not want to answer it, right? Imagine you ask a question, what is your sexual orientation? It's like, okay, that question is very sensitive. Like, I don't want to answer that question. And, and then coupled on that, there are now differences among subgroups in how they respond to the question. Maybe females are less likely to even answer the question itself than men, or maybe there are some, there's some subgroup differences that show, differential patterns in response to that question. The question itself is already sus. The question itself is already triggering people. Plus, we now have patterns, differential patterns in how people respond to it, right? So that is what we call missing not at random, right? With missing not at random, it's a wastebasket category. Once we cannot decide that it is MCAR or MAR, then by default, it is missing not at random. So the most important thing you need to know of MNAR is that if there is something about that question, an external factor that makes people not want to answer it. Maybe there's a social element to it. Maybe that question triggers pains from the past. Maybe there are social pressures. That has nothing to do with the questionnaire. If this person is bringing their baggage along, that question is triggering people. Well, then that means that if there are missingness on that question is responsible. That question is responsible for its own disappearance. And then the neighbors may also be responsible because maybe males or females may have differences in how they respond. So that is MNAR. So and so that is how we want to understand this. So the question here, the pop quiz for you was, is MAR, sorry, this is MNAR, is missing not at random testable statistically? This is MNAR, not MAR. What are your thoughts? Is missing not at random, can we test it statistically? Yes or no?
Faraja? Please unmute.
Yes, can you hear me, please?
Yes, we can hear you clearly.
Yes, thank you for this floor. So, on my point of view, as long as we do have some responses, some data that can help us, to track all the data set that we are analyzing. I think not at random, missing data can be statistically tested.
Okay,
I think as long as we do have some responses inside, they
okay,
can
thank you.
guide us, to view or to test all the data set we do have.
All right, thanks. Any other perspective?
Uma?
Yes, hello.
Yes, hi.
Yes, thank you. On my side, the answer is no. There is no formal statistical test to definitely determine if data is missing, not at random, as you said. And MNAR is characterized by the missingness being related to unobserved data itself, making it challenging to test directly.
Excellent. So this is an extremely important point. There is no statistical test that you can apply and say, oh, it's missing not at random. None. Not so it's not even an issue of, well, there's a test that exists, but it's limited. No, what we're saying is there's no test. So the question then is, this is now another question. If there's no test, how then do we know what can we then use to indicate that it is MNAR? I'm looking for a word that begins with C, the letter C, C for Charlie. If we're not turning, if statistics cannot help us, what then can help us?
Okay. Emmanuel?
Okay, I think the only solution we can get is based on the context.
Okay, thank you. I'm looking for another C word. Context is also correct, but I'm also looking for another C word that is not even as fancy as context. Context sounds so contextual. All right, any other thoughts for the C word?
Yeah, so Doug, we can do a cross tabulation.
Oh, cross tabulating, you're already going to the realm of statistics now. I would say we cannot turn to statistics. So what's the common word that I'm looking for? I've given you a hint already.
Someone said chance, cross-check.
No, much more common. So I'm just dropping the hint for you and I just need someone to pick it up.
Dr. Amadu.
Good evening, Prof.
Hello.
Could the word be check?
Okay, the word starts with common. So complete the word. Common what? Okay, if you don't know, you can say pass.
Pass.
Okay, pass. All right, who else wants to try?
There's Abdul. Abdul?
Common sense.
Excellent. Common sense. This is the most important test for MNAR, common sense. So, because remember that once we find that this guy is implicated, oh, it's MNAR. It doesn't matter whether we don't have to worry about any other thing. Once the guy is implicated in his disappearance is MNAR, right? So you have to look at this question and say, does it make sense to believe that this question will have triggered some sort of response, right? Is there something about this question that, and by common sense, I mean it's not just just lay knowledge. This is where your expertise as a researcher comes in. Your knowledge of the subject matter comes in at this point, right? And this is why no AI system can just replace you as a subject matter expert in determining the kind of missingness or how to handle it. Because for you to handle missing values, you need to first of all determine the type of missingness you're dealing with. And like we've established, this most important category has no statistical test. There's no objective way of determining it. Now, you who are boots on the ground must tell us, how is it missing and why do you think? So there's that element of context, like somebody correctly said. And we're looking at context and we're applying common sense and saying, well, it's very clear here that this is MNAR because this question, for whatever reason, fill in the blank, right? So there's a theory behind it. So this is not where you turn to statistics. Stats can't help you in this one. You have to use common sense and context to determine whether data are missing or at random. Very important. All right, so taking everything we've said, we want to know that the road to heaven feels like hell and the road to hell feels like heaven, right? So beware of quick solutions. Like, oh, just one click here and this is all your problems are gone. that never works. That's just oversimplifies the problem. And like I said, AI cannot solve the problems of missingness because you require strong, knowledge bases for the context, and you need common sense, which is something that AI doesn't have. And so, given the complexity of this, it is obviously clear that we need to focus on prevention other than cure, right? Next week's lecture will focus on statistical approaches, diagnosis of missing values, and we'll then, upper week discuss more about the approaches to handling missing data, and with a focus on inverse proportionality weighting, but that's down the road. We'll talk about that when we get there. For today, the goal is to set us on a level where we are singing from the same hymn book, so that when I say MNAR or MCAR or MAR, you all understand what that means, so that we can have a conversation about how to address them in subsequent weeks. So today's session is more of setting the baseline for all of us, so we have common terminology and can understand each other very clearly. So, like we said, MVP here is context. We need context and we need common sense. So this is why you cannot just turn to AI and say, well, help me with my missing values. Now, let's pivot now to the prevention part, because we said today is about prevention. So today I told you, today's the dental themed lecture. So for a dentist in the house, this is for you. So to prevent missing data, we need to understand how they arise. And like we've established earlier, missing data are similar to missing teeth. The question then is, how do people have missing teeth? Well, there are two explanations. It's either they were born that way or they became that way. So you were born that way, or there are some congenital malformations that will result in people not having teeth. For example, ectodermal dysplasia. I feel so clinical saying these terms. Anyway, that's funny. So you have congenital malformations that will result in no teeth, so you were born that way. But it's also possible that a dentist yanked off your teeth too, right? You were not born that way, but suddenly you have missing teeth. That exact same thing happens with missing data. It's either they were born that way or they became that way through some process. So let's look at it. Again, you're born that way for missing data or you became that way. Now, how could missingness be born that way? Well, there are two dimensions here. It was either intentional or unintentional. So intentional means obviously that it's by design. And by design means it was created by the designer. The designer of a study is the investigator. So missingness could be planned from the very start. And we have a big problem on our hand when you should have planned for missing values, but you don't plan for it. This is what gives rise to data cleaning. Data cleaning essentially means that you are supposed to plan for intentional missingness, but you fail to plan for it. Now you have to now come and worry about the issues that you failed to plan for. So this arises because you failed to plan for missingness. So intentional missingness is by design. We want it. It's like the case of missingness that I told you that is intentional. Well, here we are intentionally creating missing values. So for example, when we have skip patterns, we say, okay, answer this question. This question 2 is not eligible. You're not eligible for it. So we're going to skip you to the next question. Well, the individual is going to have missing values for this second question, but that is by design. Now, you can imagine how ridiculous it will be for you to use an AI algorithm or whatever software that is telling you they're going to do wonders for you. By the way, this software was written by a college dropout who has no idea about research, right? But he said, okay, well, we're just going to take the average and feel everybody. Like, that makes no sense, right? So our job as researchers is to question and not just accept things because they come packaged in a nice interface. So skipped here, this is by design, or people are ineligible. So we have screener questions, and the survey is supposed to be done or performed only by a particular group of individuals. And so we screen them, and then if they're not eligible, we kick them out of the survey. Well, it means that all the questions downwards after the screening, they will have missing values for those questions. But now that's fine. This is by design. Sometimes we also have hidden questions. When we conduct global surveillance systems, sometimes some questions are not relevant for some countries, right? But in the name of standardization or having standardized surveillance, we still include them in the questionnaire, but we don't allow people to see them. We hide the questions so that at the end of the day, everybody in that country or in that region will have missing values for that data, although we will still have a variable for that question in the data set. So that's what we mean by hidden questions. We use that a lot in large surveillance systems. But again, the missingness is by design. So imagine how ridiculous the software says, oh, well, I'm just going to put everybody the average value of the other people. That just doesn't even make any sense. It does not pass the laugh test. And then, but apart from the intentional missingness, you can also have unintentional, which is participant-driven missingness, right? So participants, they're eligible, but for whatever reason, they refuse to participate beyond the point, or they come to that question and they skip the question of their own, even though they were supposed to answer it. Or in longitudinal studies where we have attrition over time, all of us are unintentional, right? But inherent, and they're participant-driven. So, but in all of those cases, this is missingness that was born that way. But we can also have missingness that became that way. This arises when we're now dealing with data cleaning. And we'll now have to say, oh, wow, this individual has extreme values. Let's say 8888. We ask them their age, and they say their age is 1,000 years. What are we going to do with that? Do we set them as missing, or we receive indeterminate responses, right? And that process of data cleaning and processing, or if you collect data in different, databases and you now have to combine them, whenever you're doing things manually, that's always bad, because manual processing of things means that there is an exponential increase in the risk for error, right? So, so whenever you're doing things like that, it's possible that you might have, bad merges or bad appends, and you might individuals end up having missing data because you have not planned sufficiently as a researcher. So we will talk about how to prevent that, because that's the crux for the remainder of our lecture. Now, we want to understand that not everything in life can be solved by prayer. I would understand, of course, they're very, very religious people. So, but the point is that there's a room for prayer, and then there's a room for technology, right? Let technology solve the problems that can be solved by technology, and let theology solve the problems of theology. The issue of data management is not an issue of prayer. We have to plan ahead of time and realize that here are the issues that give rise to bad data that we have to correct for ahead of time. It's not a matter of doing tertiary prevention. Tertiary prevention is that we wait for things to go bad, and then we say we're going to treat. So we okay, let the patients get tuberculosis, and then they'll come and then we'll treat them. That's bad, right? For preventable conditions, every case that shows up in hospital is a failure of prevention. The same thing that applies to data cleaning. The conditions that give rise to poor data are things that can be prevented. And so when we now have to wait and say, oh man, we want to now pray for discernment to clean data, that is a failure of data quality checks, And so here are some of the things that you might be doing that might be contributing to poor data quality with missing values. You're begging people to obey instructions. One thing you have to realize that people don't read and people don't listen to instructions. So when you start telling people, please only answer this survey if you're eligible, oh, nobody's going to listen to that. You're going to have a whole bunch of bad responses. And then you now have to start coming and assigning them with missing values. And that very process introduces error into the system. You have failed to prevent duplicate answers. So the individual does a survey and then they're like, oh, I'm not sure whether I did the survey or not, but I will still go ahead and take it again. Now, that is so bad for many reasons. But then in the process of taking the survey, they're like, oh, okay, I remember I've taken the survey. I'm going to stop now. Now you have too many problems on your hands. You have the issue of clustered responses within the data set, and then you have issues of missing data too, right? What you should have done is to create an infrastructure or create a setting that will prevent duplicate answers from the same individuals automatically. Again, things that should be handled by technology should be done by technology. These are very easy fixes that you can just implement as technological solutions in your survey, as opposed to allowing bad things to happen and then praying for divine intervention. The same thing with fields like numeric fields. Why are you allowing the person enter a value of 1,000 for age? Why did you not program logic or validation so that it prevents that from happening in the first place? Also, if you are going to administer a survey in different languages, why are you administering each language as a different survey? Why don't you administer one survey as multilingual so that you don't have to worry about issues of manual append or manual merges? Again, the issues of complex surveys or surveys that are overly long. If your survey is very long, you would end up having many questions that people don't answer because they're tired. Fatigue is a thing in research development. So being very mindful and just even considerate. You should be considerate of people's time. Just because you can doesn't mean you should. And if your survey is going to be long, well, compensate them for their time. I mean, time is money. Think of incentives, think of technical glitches, especially in places where you might not have internet. How are you going to collect data? And then the time of year, or even the time of week, the day of week matters. If you try to launch a survey during the Christmas period or the holiday period, well, people are busy. People are not even in the mood to even do any surveys at that point. Or, so timing also matters. And the relevance to participants. So a big cause of poor data quality is about the choice of tools we use. And as researchers, you need to just have some level of respect for your study, right? So you need to figure out the tool you're using, is it fit for use and is it fit for purpose, right? And so at minimum, whatever tool you're using to collect data for a study, and again, we're talking about research studies. I'm not interested necessarily in scenarios where you are collecting evaluation for a class or you are doing a survey for a wedding or a party. You can use any tool. We're talking about serious research studies. Whatever tool you're using should have some minimum requirements, right? And this is not necessarily endorsing one tool over the other, but it's your job to make sure that whatever tool you're using has minimum standards that will ensure that data collected are fit for use and fit for purpose. Because all of these are important in preventing missingness. One, it should have skip patterns. That way, questions that are not relevant for individuals can be skipped so that they don't even see those questions. You should have branching logic. Branching logic simply means that I've asked a question that says, do you smoke? Answers are yes and no. And then I have separate questions for those who answered, yes, I'm a smoker, and separate ones for those who said, no, I'm not a smoker, right? As opposed to allowing people who are non-smokers see all the questions for smokers, and then you have bad data, and then you have to start worrying about cleaning the data and have to worry about missingness. If you can provide incentives, great. Obviously, the tool should have the capability to provide incentives so that people are encouraged to complete the survey. Codebook generation is very important. The codebook is a data dictionary. Very important. Prevention of duplicates, very, very important. If you're using a tool to collect data, and an individual can come and take multiple surveys, that's a huge problem for issues of data quality. Again, it just boils down to having some degree of seriousness about your work. If that work is that serious to you, then there are minimum standards that you should meet in terms of the tool that you're using to collect data to minimize the risk for poor quality data. There should be a way for you to assess the quality of each participant's response. And very importantly, the ability to pause and resume. I don't want the individual to pause the survey and then when they come back, start a new survey altogether. No, if they pause the survey, they should be able to resume from that point where they paused it seamlessly, right? These are minimum standards. So we're not saying the survey platform should, launch. It doesn't even matter which particular platform you use, but whatever tool you're using should meet these minimum standards. If I supervise, several, graduate students every year. And no, you can't just bring for example, there's no way I'll allow students I supervise to collect data on Google Forms because that's not a research platform. That's not a research tool for serious work. Sure, you can use it for a whole lot of things, but not for work that is as serious as what we're doing because it does not meet the minimum criteria for what we're trying to do. You should also, apart from tooling, we also have to have a conceptual framework for how we collect data, how we design data to ensure that it meets the intended use, right? So in simply, we want to have one flow. One flow means keep the questionnaire focused. It should have just one large coherent thought, one mind. Don't influence the participant's answer. The answer should only come from one individual's mind, the participant's mind. So don't try and inject leading questions that would bias responses one way or the other. There should be one answer. For single response questions, answer options should be mutually exclusive and collectively exhaustive to capture all possibilities without overlap. Now, one column per indicator. This is just basic data standards. You can have data collection where that same column is capturing many things, right? One column, one indicator. That's very, very simple. Again, these are basic data standards that we need to adhere to when collecting the data. You don't want to have a long list of questions. 1 dozen is enough for number of questions in your survey. I mean, the key questions. Then you can now add the demographic variables. Then one database. Even if you're doing a survey in multiple languages, even if the survey is in different populations, well, that is why we use logic. The whole point of using survey logic is to allow technology to solve the problems that are technological problems, not that we'll now collect fragmented data and then we'll now want to start putting them manually together and then create all manner of errors. It just shows you don't take that work seriously enough. And then you should have a code book, one code book for all sites. All right, so we're going to look at a last part of our lecture now is just quickly look at a case study. This is just a quick survey with 3 questions. The idea is to look at how we should, when we're setting our questions, how can we plan for missingness? Because remember we said there's intentional and unintentional missingness. You must plan for intentional missingness so that you don't get bad data, right? Because if you are supposed to plan for intentional missingness and you did not plan for it, well, now you have to worry about cleaning the data afterwards, and then all manner of errors start appearing. So here, our case study is based on attitudes and experiences in handling missing data among researchers. So this survey is intended for individuals who have published a research paper. And so the first question is, how many peer-reviewed research papers have you published, right? These are the response options here. Now, since the target population is individuals who have published a paper, it makes sense that individuals who have said none should be skipped from taking the survey. They should just, because this is our inclusion criteria, right? We want to see how this pans out when we collect data and how we manage those things. Then this second question here, the goal of asking this question is to see how we should think about skip patterns. So here we're asking the person, how often do you encounter missing data when you perform analysis? And among these options are people who said never, or I don't analyze data. Well, that means that question 3, when we're asking them about challenges they've had with handling missing data, these 2 individuals should ideally not participate. These are the problems these are the issues that end up giving us bad data that will now have staff to worry about cleaning manually. And then we'll start talk about missing data. So we need to think about all of those things. And so what we're going to do now is to take this survey. So what I've done is create a link on two surveys, one to create a problem, see how the problems arise for us. So I have the link to a Google form to look at some of the challenges we might experience when taking, so let me go to the browser. So this is the survey on Google Form. So what I'm going to do is I want to share the link with us. So we'll take the survey and then we will look at the responses. We'll look at some of the challenges we might experience, and then we can look at how do we look at them, right? And then we also have a second survey just to set a gold standard for what we expect data collection standards to be as researchers, right? What's the minimum standard you should aim at and consideration? So here I have the survey on Google Forms, which I'm going to share with the link. And then we'll also look at the same survey on the Chisquares platform and see, and that's just to set the benchmark for the quality standards that we expect, right? At minimum, that you should strive to maintain when you collect data. So this is the survey on Google Forms, and then I've created the exact same survey on the Chisquares platform. And for those of you who are not familiar with the Chisquares platform, it's just a research tool that that's it aims to be a one-stop shop. So here I have tried to address so many of the issues that we talked about that you need to consider when collecting data to ensure high response rates. I have tried to make it as comparable with SurveyMonkey, with the Google Forms. So some of the features that are not available in Google Forms, I did not add them to the survey. But you should absolutely consider things like translation, right? How do you administer survey in multiple languages? If people don't understand the question you're asking, then likely they will not answer it, and then you have missing value. So consider having multiple languages. Consider also having incentives. Everybody wants to make a buck, right? So if you have incentives, and you don't even have to have $1 million to offer incentives. I can have $50 and say, well, I want to actually offer a raffle draw. I don't have enough money to give everybody, but I want to say I have a raffle draw for 2 lucky winners. You get $25. Now, that will still improve response rate and will reduce the risk of missing values. So let's just go ahead now and take these 2 surveys, and so we can see what lessons we can draw from data capture and mitigating missingness when we collect data. So I'm going to drop the 2 links here. Let me see. This is that's the first link for SurveyMonkey. So we're going to look at the data from the 2 and look at lessons we can draw so that when you are in one situation, if you've collected data on Google Forms, what standards are you expected to bring your data to for accurate analysis? So that's what we're trying to answer here. And let me copy the link for this one here too, so that we can have a side-by-side comparison. So let me copy this and share. So I'm just going to give a few minutes for folks to take the surveys, and then we can then download the responses and compare them. So I've dropped the link. So please take the surveys if you can, so that we can look at them together. So I'm going to give it a few minutes for folks to take the surveys, and then they're just 3 questions, nothing really complicated. Right, I think we have quite a bit of responses here now. So let's All right, let's resume, and let's now take the responses, the data sets, and have just a very critical appraisal of the challenges we might experience, even with just this small survey, and how to address them. So let me go back to share my screen. All right, so let's start with so we have 111 responses. That's awesome. Now let's download the data. Let's see. So download responses. Okay. All right. So this is the response from the from Google Forms. So first of all, let's look at some of the things that we need to worry about when we collect data on in a form like this. All right, so here we have, so the first thing you'll have to notice is that you will have to create variable names. The variable names appear as the original questions, right? So now you will have to create a code book, right? If you're using a software like Google Forms, well, you will now have to create a code book that allows you to start manually creating variable names. This is extremely important for the sake of, data cleaning and harmonization standards. So here you have to now start manually assigning variable names. So here, papers determine that this is the variable name, and then manually I have to set the variable name here, because you obviously cannot analyze a variable that has a paragraph as this question name. That makes no sense, not possible, right? So that is the first thing we have to do. So we see here that one of the challenges we have to address is that there are no variable names that are created. We have to manually do that. And again, like I said, whenever you're doing things manually, that's always creates room for error. So we want to avoid manual work as much as possible. Then we have here, remember that our survey was supposed to be only about people who have published, right? And remember we said that people don't listen to instructions in general. Participants don't listen to instructions. So individuals who had not written a paper, so let's filter individuals here. So individuals who said none, oh, they were supposed to end the survey. But here we see that individuals who have answered none have still gone on to answer the survey, right? That creates problems for us, because now we have to now manually start figuring how do we manage these responses, how do we address them? This is the problem that arises when you implore people, please don't answer this question if it does not affect you, or if you're not part of this population. But every time you are begging people or you are imploring on people to do something, that you know that you have failed already, because you are supposed to have used technology to solve that problem, but you are allowing people to decide whether or not they want to comply. That is not the right way to do it. So, so this is a failure on our part. And the reason why it's a failure is because, well, the tool we're using is not necessarily designed for research per se, right? So it does not allow us with the ability to set those restrictions. And so now we have to do all of this manually. Then the next problem we now have with is here in the third column, where we have multiple response options, right? So here we have, again, remember, one of the core data standards in data science is one indicator, one column. Now we have a little problem here. We have a problem of multiple indicators are all strung together in one column. So here, you will now have the work, because here, for example, this option is deciding whether to exclude individuals from analysis, concerns about small sample sizes. So all of these things are in the same column. This is a no-no. Obviously, you cannot analyze data this way, right? And then you also have scenarios whereby individuals who provided a response like no other concern, like this individual here. It says, I have no concerns, but then they still proceed to provide other concerns that they have, right? So you have issues of responses that were supposed to be exclusive being coupled with those. Now, this is where we said, remember we said either missing values are either born that way or become that way. So now you have to start making those decisions manually, right? So this is why, for all of these reasons, when the most important job you have as a researcher is to ensure that the tools and approaches you're using are fit for use and fit for purpose. So you're just doing a survey to look at evaluation of your students' work or invitation to an event, sure, you can use it. You can use any tool you want. But if it's especially if you are a graduate student and this is work for your PhD, for your master's, well, you should be a bit more intentional in the technology you use to make sure that it meets minimum standards. Again, it can be whatever tool you use. This is not an endorsement of one tool over the other, but at minimum, it should meet minimum standards for valid data capture. All right, so the goal of doing this on the platform was to show you what the data standards we expect should be. Like, what data standards should you aspire to? Because it's not enough for us to say you should aim at the standards. Well, what are the standards? What data standards should you aspire to? So let's again download the data. So go to manage collect data and let's download the raw data sets. So the platform Chisquares platform gives you both the raw data, but it also automatically cleans your data set for you. So I'm going to download the raw, but also I'm going to download a clean data set. So let's look at both of them. Let me look at the clean first, so that we can look at what we expect as minimum data standards when you're collecting data. So here, this is the clean data set that has been captured by the platform. Now, for you to understand the clean data set, you need to have a data dictionary because you have certain variables created here. So you have the unique ID, you have the, these are all metadata. Metadata means extra variables that you did not collect in your survey, but are also captured in your response data set, right? So you need to understand what this means. You have another variable here called the language for the survey, which is in English because all the responses were in English. If we had the survey in multiple languages, the language will be indicated here based on these ISO codes. Then we have the data quality score. Each individual in the data set has a score assigned to them for possible issues that might have arisen with the data. Maybe they answered the survey too fast or whatever. These are all captured and you need a code book. We're going to look at that in a minute. But then you also have the response options here. So this was the first question about the manuscript. Oops, let me go back there. So this was our first question about manuscripts. So again, they are in the clean data set, everything is coded as one numeric form, right? And individuals who have missing value. So for each variable, you have a missing value. So this is the variable for the first indicator, and then you have M stands for missing values, right? So if an individual had a missing value, see, this individual here has a missing value, and it tells me the kind of missing value it has, right? So you see that consistently in the clean data set. P here stands for partial complete. It means that this individual never got to that question. You have I here stands for, because it's not enough for us to say the individual has missing value. The question is, what kind of missing value do they have? So, because knowledge of that is very important for us to be able to know how to deal with it, right? So this individual here had missing value for this variable, and this is telling us that the code for missingness type is I. I stands for ineligible. So that means that this individual did not meet the inclusion criteria for the study. That is why they were never served that question, right? So this is what we expect. And then here you see for the multiple response questions, these questions have been created as dummy variables. Dummy variables means variables that are coded as 0 or 1. Whenever you collect data from a multiple response question, which is select all that apply, the question must be coded as 0 and 1. That's the only way you analyze a question that is multiple response, right? So at minimum, we expect that you should have each of those indicators in a separate column of its own, not all of them like mashed together in one single column. Then you now have to start manually separating them. And again, whenever you start doing things manually, the room for error has increased exponentially, right? So the idea is that no, it's always a bad idea when you're doing things manually. So for you to understand and so that's the clean data set. This was the let's look at the manual one or the raw one. So you can use the raw data set, or you can use the let me pull up the downloads. I downloaded both of them. So let's look at how they compare, how the clean data set compares with the raw data set. So the clean data set is always as, you have codes instead of the raw actual responses. So this is the actual raw responses here in the raw data set. So the rationale for providing you with both a clean data set and a raw data set is for those who like to suffer, who say, oh, I actually want to clean it myself. Well, you can go and knock yourself off, right? You can do it. But the platform already does that automatically for you based on, statistical principles here. So here you have you can see here, instead of having codes, you have the actual raw responses that you can then use. But even for those, the multiple response questions are still captured in different columns. So let me expand this so we can see that clearly. So these are the response options here. So for this individual, for example, that answered none, that means you will see there's no other answer subsequently because they are ineligible for the next set of questions. So it would be ridiculous for you to now start saying, I'm going to give an average value for this individual. Well, that was planned missingness. So it's a desired missingness, so that when we're analyzing our data, only individuals who were eligible for this question have responses for subsequent ones, right? So, but again, regardless of whether it's the clean data set or the raw data set, there are some minimum standards that apply based on the type of question. And in this case, questions that have multiple response questions or multi-selections, each of the response should be a separate variable of its own. So even if you're not using a platform that automatically does it for you, like the Chisquares platform does, even if you're using let's say Google Forms, you will have to manually create something like this, right? Such that, each indicator is in one column. You can have multiple indicators in one column. Now, you also have to create a code book. You can't talk about managing missing data or, without talking about code books. So if you're using the Chisquares platform, that is also done automatically for you. So let's look at the code book and let's see what it means exactly. So let's look at the reports here and download the code book report. The code book essentially, as the name implies, is a book of codes. It tells you what each value means in the clean data sets. So let's download that first and see what that looks like. So this is the code book here. So like we said, it's a data dictionary that tells you every single thing in the data set. It tells you the patterns of data. Like this is a data quality score we're looking at. It had values from 0 to 1. And so 1 means that the individual is a suspected duplicate, right? And so on and so forth. It looks at the speed at which the individual completed the survey. If everybody was taking the survey under 30 minutes and you came and took it under 3 minutes, well, that's very suspicious, right? Based on statistical distributions, we can tell that, well, you took the survey very short. So, of course, there's no set time for any given survey. But statistics can tell us whether your survey time was very, very short relative to the rest of the distribution. And all of those things are factored in, so you have a data quality score. Then for each variable, you have a code. So when you're analyzing the clean data set, you have the code that explains what each value means, right? And so this way, when the questionnaire says number 3, you know that number 3 refers to rarely, right? So that allows you to be able to make sense of it. And for management of data, before you start going to the questionnaire and trying to make sense of it, it's always a good thing to look at the methodology as well as the overall descriptive analysis, right? So on the Chisquares platform, for example, you would come to download reports. There are different types of reports you can download. Apart from the codebook reports, which we just looked at, you also have the methodology report, which tells you about how the survey was conducted. So let's look at that quickly. So it tells you essentially the methodology of how the study was conducted, like dates and time and other contexts. So let's look at that. So, alrighty. So this is our methodology report. The previous one was a codebook report. This is the methodology report. It gives the background and motivation for the study. It talks about the study design. This was cross-sectional. It talks about the study participants. Here we have from 151 individuals. And this is very useful in cases where you just have to send a report and you don't have to. So from an efficiency perspective, this is very useful. If you want to share a report with partners, for example, you don't have to go and start writing one from scratch. And so it gives you basic elements of the survey that gives you an idea of, okay, this is what the study is all about. But from the perspective of managing missing values, from next week, we'll be talking a lot about the analysis report, right? So the analysis report is essentially an overview of the data. It describes the data in terms of, so let's look at that. So survey analysis report. So this is our analysis report here. We downloaded it for all participants, which is 161 individuals. This was date and time of the report. So for each question, we have, so for example, Q1 was a multiple choice question. The denominator was 107. It is very important for us to know the denominator of each question. This is extremely important, right? How do we calculate the percentage? Well, the number at the bottom of a percentage is what is called the denominator, right? So each number here is divided by the denominator. At any point in your analysis, you need to be able to know what the denominator for your analysis is, all right? So this is provided for you here, and of course with the visualization of each. So the analysis report allows you to have a very high-level view of the patterns of responses and to see the degree of missingness overall from the different questions before you start analyzing, so that you can then make sense of it. Anyway, I'm going to stop here so that folks who have questions can ask them, and then we can schedule for next week for follow-up in more details of the diagnosis and then subsequently the management. All right, any questions now? I will be happy to take them.
Samson.
Thank you very much, Prof. I've been following for some time. This is an insightful presentation. My only problem is that now that we are understanding the Chisquares platform, that we want to use it, our free period is elapsing this April. Is there any way it could be extended for us? That's the first one. Now, my major question, assuming we've used a Google form to collect data already from some people, and we would like to analyze, is there a way we can put that Google form, maybe in Excel format, into the Chisquares platform and get the updated data, or the edited data, the revised data that we can use for maybe data analysis? Thank you.
Yeah, so you can. So for the first question, well, there will always be a free plan for individuals. Of course, the free plan will have limitations, but that will exist. For the second question, the issue of import, yeah, you can collect data on anywhere, and you can import that data into the platform to generate a report for you like this. So you don't have to. The whole idea is about how do you optimize efficiency so that the researchers should spend time on things that are more worthwhile than just manual labor that doesn't add any intellectual input. So that's the whole premise here. So yes, you can bring the data and upload it and it will generate a report so that you can then focus more on the intellectual aspects of interpretation and context and all of those things.
Darren.
Thanks, Longile. Hi, Prof.
Hello.
Can you hear me?
Clearly, yes.
Yeah, this is Western.
Hey.
Well done. Yeah, very good job that you're doing on Chisquares. I thank you very much. I've been following you for close to a year. And I have a question about the cross-sectional survey feature of the Chi-Square platform, which I have used.
Okay.
And one feature I really enjoyed about it was that I was using the same link to collect information on patients undergoing cataract surgery at different outreaches that I do. So I noticed that recently, it seems there has been a change. I can't use a link another time. It will tell me, sorry, you've completed this survey before. And I can't use it for multiple patients. I understand the rationale for that. It makes perfect sense. We don't want people who have responded before to give multiple responses, which can affect the quality of our data. But for my own situation, that feature is useful in the sense that I can use that same link to collect serially for patients. So my question is there a way that feature can be adjusted by the user of the platform? Like yes. I can allow that link to be used several times, like the way I used to collect data previously.
Yes, there is.
Please, if it's possible for us to do it that way, if you can please show by demonstration how I can change how many times a link can be used, I'll be very grateful.
That's a very good question. Let me show you. Yes. So every single thing on the platform is at your control. So if you are in doubt, just go to the settings and just read through the settings, and I guarantee you will stumble on what you're looking for. In this case, you click on the settings here, and you come to the manage study. So at the bottom here, let's look at some of the different options here. So let's start from here. Control multiple entries. This allows you to control multiple entries. The default option is block multiple submissions completely, right? That's the default. Now you have options to change this. You can say allow multiple individual submissions at the start. So that means that if you enable this, right, an individual can just take the survey as many times as possible. We set defaults to align with data standards. So your use case is more of the exception than the norm. The norm is that, yeah, I would not want individuals to take the survey multiple times. So that's why it's the default. But in your use case, you can just come here and say, well, I want multiple, because it's not multiple individuals per se. You're just using your device to collect data multiple times. But the technology just sees it as the same individual, right? That's why it's blocking you. So in this case, you can just come and allow multiple individuals to take the survey, or you can use this one that says allow resubmission at the end. So in that case, what it does is that it adds a button at the end of the survey where you can just say submit a new response, and then it will take you to the start. But either of those two options will address what you need. But this will be the best one for your use case, where you can say allow multiple individual submissions, and then that problem will be solved for you. I hope that makes sense. And of course, you should save the settings when you're done so that it takes effect.
Bikila? Oh, oops.
Thank you very much, Prof. Really, it's good and nice presentation, and the way of present this, the content is more clear and nice. Whole presentation thing is as the in it linked to the Chi-Square platform because the Chi-Square it's free feature. I try to check it's free features and it's good. But I'm Kla from Ethiopia. This is free, but it will be premium. So to use it more, it's detail and for data collection, even data analysis. So as a country, it's no means to get the premium feature of the Chi-Square or your platform. So how what we can do to get the more and detailed, even if we can, the backend of this platform for data collection. And lastly, I need as individual or we need more detail training concerning this platform or Chi-Square data collection or data IRS platform. This is my question.
Okay, thank you very
Thank you
much.
very much.
Thank you. I think I deduced that your questions were, what about the cost? How do we support people from countries who do not have a lot of money? And number two, how do we provide additional training? So the first question is that yes, the Chi-Square platform will always have a free option, right? And and then we also have a prorated or a discounted amount for individuals who are in A and B countries, which is low and middle income countries. So that would always be there. So between those two options, you should be all set. The second question about training, we pretty much have a lot of training programs. So just make sure you follow us on LinkedIn or other social media. And we also work with institutions. So if your institution, for example, wants to partner with us, that's also something that we can consider. But yeah, those will be my thoughts on your two questions. All right, next question, please.
Shabo.
Okay. Can you hear me?
Yeah, we can hear you. Yes.
Hello.
Yeah, we can hear you clearly.
Okay, thank you, Professor. Okay, thank you. Thank you, Professor, for your presentation. I really enjoy it. But I have two questions. First of all, I'm Shabel from Benin. And my question is, for the last question that for the link that we have completed, when we will be willing to describe that variable, or that the graphic, or how is the way to present that question? I don't know if you get me very well, because it's a more response question.
Okay. Okay. Yes, I understand.
And also, when we will be willing to go further and go to inferential statistics, if whether, for instance, we want to know for the challenges that the person face, if whether he used the Chi-Square platform or not, if it's linked with that challenges, or how can we manage if we will use each modality that will become a variable in our data set to do the Chi-Square test, or we use the variable that keep all the modalities with comma, and like duplicate the line and duplicate the modality that correspond to that and the Chi-Square test. I don't know if you...
Yeah, I understand you. Your question is, in this case, we have a multiple response question that was, for example, captured in one line. So when we had So this is how it was captured in, let's say, Google Forms. But this is an incorrect way of capture. You cannot analyze the data this way. This is not qualitative data. This is quantitative data. So for the sake of quantitative analysis, you cannot analyze data this way. This data is not fit for use in its current form, right? And that's the whole point of showing you a similar way of the corresponding form on what are the minimum standards for data capture. This will constitute what you should view as a standard. This is the standard for how data should be captured for analysis. Each item must be in a column of its own, right? And must be dummy coded. Then if whatever analysis you're doing, you can consider each of these as individual or separate columns or variables. Sure, they were all together in one question, but for sake of analysis, they are different indicators altogether. So that's how you should approach it.
Okay. And what about the descriptive statistic?
That depends on what you're trying to do. Descriptive statistics is not just one thing. It could be anything. So, our focus should be on understanding what we're trying to do and in telling the story. Sometimes I think we sometimes put statistics first without really understanding the story or what we're even trying to say. So I think that the statistics should come secondary after we have a clear picture of what we're even trying to say. So have a clear picture of what you want to say. Have a clear picture of how you want to collect the data. Plan for missingness where appropriate. Know how you're going to collect. Those are more important issues than the statistics is important, but it can come much later. For now, the foundation is important, making sure that you're capturing things the right way and the way that makes sense.
Okay, like if you want to know the challenge that's come mainly, and so or something like that.
Yeah, if you want to know the challenges, yes, you're going to assess them in the questionnaire. And if it's just descriptive analysis, the platform already does that for you with the methodology, with the analysis report, so that you don't have to even do that manually. The whole point of this is to say, what are some of the things that are just manual that can be automated? So, so that problem is already solved for you. So you can just grab the analysis report and then look at it. That will suffice for your descriptive analysis.
All right, I got you. Okay, great. Thank you so much.
You're welcome. Yeah. Next question, please.
My data is collected from animals and all in Excel spreadsheets. How can I load it to Chisquares platform to further analyze it?
All right. So we're releasing the version 2 of the platform in a few weeks. So then you'll be able to do that, and not just descriptive analysis, but also advanced multivariable analysis. So, but we're going to announce when we eventually make the release.
Shamsuddin. Shamsuddin.
Hi. All right. Thank you. Thank you, Prof, for the insightful lecture and the knowledge disseminated for free. Thank you so much for that effort. So, I have a question around the multiple imputation. From the beginning of the lecture, you mentioned that using AI to address any missing data will be very erroneous, which I agree with 100%. But the point you mentioned that what the AI does is actually taking the averages of the numbers above and below to fill in those gaps of the missing numbers. So I'm going to share my understanding of the multiple imputations and that's exactly how I assume the way it works. So like, for example, applying that in SPSS, you can see the iteration numbers, like taking the averages of the numbers or the data point above the missing one and below the missing one, just so you can take the average. So what that means is, what I understood from the beginning was the imputation, the value you get is actually an average of the average. So it takes the average of the 5 numbers above the missing one and the average of 5 numbers below the missing one, then take the average of the 2 numbers. So that means it's taking average of the average to fill in that gap. So this was what I understood, because I think I read it in some of the books, but you mentioned that a lot of, faulty information are out there. So I don't know. I just want you to please shed more light on that. Thank you, Anova.
No worries. Yeah, thanks. Yeah. So first and foremost, right, what we're prioritizing is context, right? That is very important. So in this case, let's go back to this raw data set. Hold on a minute. So beyond any statistics can come back later. We'll talk about the statistical issues later in week 2. For now, we're trying to make sure we understand we are all on the same foundation in terms of just issues of philosophy and logic and reasoning, right? So here, for example, this individual did not answer the survey. They don't meet the inclusion criteria, because the inclusion criteria is individuals who have written more than one paper. So if you answered none, you are missing by design. Will you think it's appropriate then to, whether it's average of averages or whatever, to fill in the value for this individual who is missing by design? Do you think that makes any sense? I don't know if you're still on the line. Okay, maybe not. So what we're emphasizing today is not some statistical procedure, or what the statistics mean. No, we're going to cover all of that in week 2. What we're emphasizing is the role of context. That not just because this guy is missing does not mean I have to impute him or do any procedure, right? Because it's missing intentionally, right? The software does not know why he's missing. The software just sees the missing value and like, oh, let's just pop in averages here. But that makes no sense. So that's why my emphasis is on the role of context, that you cannot substitute the machine for you. You have to be there and understand. And and you also need to understand the different types of missingness and when one scenario will be appropriate for one, but not appropriate for the other. That is way more important than any other, issues of computation. And next week, then, when we're discussing the more of a statistical aspect, then it might make, then your questions will be more, will be answered. But for today, what we're saying is we should apply common sense to understand what is going on in our data and why things might be missing, and when it makes no sense to even attempt to address the problem of missingness. If the guy is missing here because he's ineligible, then what are we even trying? What are we even saying? Why are you trying to give him an average of others when he's not even eligible for the study? That makes no sense. So I think that's the important. So let's put statistics next in the back seat, and let's put like just the basic understanding and the intuition for what we're saying in the first seat. So if we can do that, we can declare the lecture as a success.
Thanks, Prof. Shadi. Interesting. Shadi.
Thank you, Prof. I'm Shandrak Mutoka from Kenya. Here in Kenya, we mainly use ODK, which is an open source mobile data collection platform that enables to collect survey data. Now, my question is, does ODK meet minimum standard for data collection? Thank you.
Thank you. So our job here is not to endorse one software over the other or tell you that this software is bad and that. No. Our job is to say these are the minimum standards, and it's now your job to go and assess that. So so you can use whatever software you want. There's no it's your data, whatever you want to use to collect the data. But it's also your job to make sure that the platform you're using is fit for use and fit for purpose. Something might be fit for one particular use, but not fit for another use, right? And if you're also a supervisor, if you supervise students, masters or PhD students, it's also your job to ensure that the tool they're using is fit for use and fit for purpose. Otherwise, it just betrays the seriousness of the work we're doing when we use a platform that is not fit for use to collect work that is of extreme importance. It just suggests that we don't have a very high view of that work itself in the very first place. All right, next question, please.
Solomon.
Prof, for that insight. My question is on the use of Square platform to link
Sorry, you are
the
waiting in and
Square
out.
platform to. Hello, Prof.
Yeah, it seems your internet might be having a little lag.
Oh,
And you can also type your
my
comments in the chat if that works for you.
Hafsat.
All right, thank you very much, Prof, for the insightful presentation. So please, my question is on, although it's a bit out of the context of what we did today, but about calculation of incidence risk. So there's this studies intending to carry out on the incidence of sepsis on children that have been admitted in an SCBU. So after I now I've now did my sample calculation, I've calculated my sample size, and also trying to do the microbiological analysis to find which ones are positive of the organisms. So please, for those, while doing the calculation, is it that I'm going to divide by the total number of the neonates or the babies that have been admitted within my study time frame? So I just want to get a clarity on this, please.
Okay, so you'd just go to the Chisquares platform and go to sample size, and you can start new sample size. Now, your study is since you're trying to calculate incidence, I assume that your study is a cohort study. You want to follow a bunch of babies or neonates over time, and then you try to estimate the incidence, maybe between one group who received a particular treatment and another that received another treatment. So that will make it a cohort study, a prospective cohort study. So you come to comparative study with two arms, if that's what applies, and you have to enter certain things. First, you have to select the study type, which is a prospective cohort. You have to provide the prevalence of the outcome among the non-exposed group, which is the control group. So let's say you are comparing a new drug with the standard of care. The standard of care is now the non-exposed group. So on patients who are on that treatment, like what is the percentage of the outcome? You provide that estimate, let's say 20. And then you have to choose one of these indicators to capture effect size. So when you're calculating the sample size, you must provide the effect size. Effect size is simply saying, how much of an effect do I want to see at minimum? So at minimum, what will I see that I will say, oh, this result is significantly different from the other? And you can express that in any of these four ways. Let's say you want to express it at odds ratios. Let's say you want to see an odds ratio of at least 1.5. So you provide that 1.5 there. Then you complete the remaining things like the level of confidence. Is the test one or two-sided? Always choose a two-sided test. A two-sided test means that, well, I think that the result might go this way, but I'm open that it might also go the other way. So you're open to the results going in any direction. That's what a two-sided test means. You provide the power desired. The higher the power, the higher the sample size. And then the ratio of non-exposed to exposed or treated to untreated. And then the response rate. Let's say I expect the response rate of 50%. I can provide that there. And once I click on get results, it tells me that I need 99 people in the exposed and 99 people in the non-exposed. So you need 198 units in your study based on these parameters. Of course, as you put in different inputs here, the value will change dynamically based on the calculation. But essentially, this is, and then if you want to look at the formula that was used, you can click on show reference and look at that. But this is how you could do it. So what you could do is try and look at different parameters and what impact that has on final sample size calculation. Does that answer your question?
Yes, it does. Thank you very much, Prof.
You're welcome.
Moses?
Thank you so much, Prof, for the session. Very informative, and we really appreciate. I have two concerns. One regarding collecting data. Usually, surveys that involve collecting a variable with different units. For example, for children, we usually find that some children, their ages are in months and then others are in years. So you find yourself collecting two variables, one in years and one in months, and it sometimes becomes a challenge at analysis. I don't know how that can be solved. I would like your advice on that. And then we have this term sensitivity analysis that we usually face in research, where, for example, I've collected a study that collects different diagnoses, outcomes from different diagnoses of mental illness. For example, you find yourself having different factors, and you want to see how specific each diagnosis is affected by different factors, and then you do sub-analysis. Does that affect it? Because the sample size for the different diagnoses kind of reduces. Does that affect the outcome? I would like to know how that can be, how a sensitivity analysis can be better analyzed in that context. Thank you so much.
All right, great. So let's answer your first question about you have age, which could be months or years. How do you capture it without capturing as two variables? So yeah, you should not capture it as two variables. You should capture it as one variable for the sake of efficiency. In that case, I would come here and select an open-ended question and say that I want a single value question. I can then say, what is your age? What, sorry, is your age? Geez, since my vision literally became bad overnight. What is your age? Please indicate whether it's in please enter a number and indicate. Every question you select, you enter must have three components. There must be the stem, there must be instructions, and there must be the answer options. If those three elements are not in your question is incomplete. So the question here is, what is your age? The instruction is, please enter a number and then indicate whether it is in days, months, or years. Sorry, pardon any typos that you might see, or years, right? So that is it. So we allow them, even for neonates, we can still collect the data, right? So we'll come here to settings and say, first of all, allow only numbers, because we don't want to start cleaning data afterwards that somebody entered some character that is not even a year. And we say provide units of measurement. So the units of measurement could be days, it could be months, it could be years. And we don't want negative numbers. So we can say the minimum is 0, and we just leave the maximum open, and we can apply that. So if you look at the preview of the question to see how it's going to look like, it's going to look like, what is your age? Please enter a number and then indicate whether it is in days, months, or years. So the user can do that now, right? So if my age is 15 months, I can just say 15 and select months. If my age is 15 years, I can select years. And if it's in days, I can do that. And that way I can push that, let's call this age. So that way you can use one question to collect data on different parameters and then have just the specification for the units of capture, which will become unit of analysis. So that way you now have, when you collect the data, it's going to be, two variables, one for the value, because remember, one column can only contain one thing. So you're going to have two variables, one for the numerical value, the other one for the units. And then you can, standardize them into days or into whichever unit you want. So that's how you do it properly. The second question was about sensitivity analysis and its potential impact on sample size. So sensitivity analysis in general, you shouldn't do too many of them, because that raises the issue of type 1 error. Type 1 error is, when we go on a fishing expedition and we're seeing results not because they're significant, but because we're looking so much, we're looking so hard. So of course, if you look hard, you're going to find anything, right? So for that reason, the sensitivity to do sensitivity analysis correctly, one, you must specify them a priori. So it's not that you do analysis and then you're like, what are the 1,000,001 sensitivity analysis that I can do now? No. Any sensitivity analysis should have been specified a priori in your protocol. If it was not specified, then it's now a fishing expedition. So you should have specified it properly then. They should be specific and there should be a clear argument for why it's been included. So I should be able to say, I am doing the sensitivity analysis because this indicator is so and so, or this marker is so and so. And that's clear so that it's well documented. There's a rationale for it. So it's not as if I'm just fishing for results. And the reason why we do that, obviously, is to either ensure consistency or coherence. Coherence is when we use different outcomes but see a similar result. So that would be the appropriate way to do it. And when you are designing your protocol, sensitivity analysis should also factor into your sample size calculation. So because you want to plan for the worst, you want to hope for the best, but plan for the worst. So if the sensitivity analysis requires a larger sample size, then you should go for that larger sample size so that it covers both that sensitivity analysis and the main analysis. So that's the planning that needs to take place first. The statistics can always come later. The stats is great, but it can always come later. What is most important at the beginning is proper planning or proper design of a study. So once we do that, then the rest can take care of itself later on. Okay, any other questions?
Link. Please unmute. Okay. How can we factor sensitivity analysis in sample size calculation?
So I think that is that a new question? Because that's what I just explained.
Okay, I just saw it now. Yeah, Moses just posted that.
So like I said, you look at every sample size calculation shouldn't just be one number that you just produce. You should create a table that says, under these assumptions, this is the sample size. Under these assumptions, for this outcome, this is the sample size. So that's what it means, right? So the sensitivity analysis is not only when you get the results. The sensitivity analysis is also in the sample size calculation. So look at the sample size under different assumptions. Because at the end of the day, like we always say, all sample sizes are wrong, right? It's just about how do we optimize for the likelihood of accuracy. So we can only do that if we test under different assumptions and see, okay, what makes the most sense in our current context. Right, next question, please.
Faraja.
Yes, can you hear me, please?
Yes, we hear you clearly.
Yeah, thank you, Prof, for this brilliant presentation. It's so very helpful to us. So my question is that in the software like Kobo Collect, this is an app for collecting data, like Kobo Collect. For these multiple answers question, we do have, for example, the possibility to encode the answers. For example, the answer, the choice A, we put the figure, the choice B, another figure, until all the choices we need, people can select in between. So you were saying that for these multiple answers questions, we have to encode them, for 0 and 1, 0 and 1. So can we confuse these answers, as we do have multiple choices? Once we do have 0, 1, 0, 1. So how are we gonna differentiate these different responses for only one question? But in Kobo College, we do have the possibility to go from 0 to 9, specifying 0 for answer A, 1 for answer B, 3 for answer 2 for answer C, and so on. So I need to have, your insight and also more development on this. Okay. And yeah, you can just perhaps come on this and then refreshing the second question.
You can answer your question and I'll just answer all of them at once.
Okay, yeah, for the second question was this, for these answers with the skip logic, once the respondent does not respond to a certain question, then he cannot go further to other questions, for ineligibility issues. So I wanna understand, once we have to present results, for example, for the first question, we can say N was for 500 people, 500 respondents. But once we move further to other questions, we need to present results for other questions. We say, because for question A, we had 500 respondents. This is our N for 500. But for example, for the third question, we do only account for the respondents that met the eligibility criteria, So we will say, for example, for this question, the question 3, we had only 250 respondents because these are the people who met the eligibility criteria. They went on the skip logic criteria, they satisfied it. So I want to understand, for such a survey, with skip logic criteria, what do we say for our N? Will we present the N, the number of respondents, according to the questions or according to each question, while we know that some questions need skip logic and others do not need skip logic. So the N general will be only for the whole respondents, or will present the N for each question, knowing that skip logic is involved in. Thank you, Prof, for these clarifications.
All right, thanks. So regarding your first question, the standard is not based on how one company is doing it or the other company is doing it. No, the standard is based on solid principles of research and statistics, right? So the standard is questions that are binary are analyzed as binary, right? So every multiple response question, the response option is inherently binary, meaning selected or not selected. It's as simple as that, right? So when you are trying to analyze, for example, the percentage who selected this, well, you have to express it as a dummy, which is 0 or 1, especially if you want to estimate it as mean, right? You end up, the method you indicated, you say, oh, I want to code it as 0 or 5. That works well until somebody mistakenly forgets that it was not coded as dummy, and then proceeds to estimate means, which gives you completely wrong results, right? So when we're designing infrastructure for statistical analysis, it doesn't matter whether one company is doing it one way. Well, or it doesn't matter whether the majority of companies are doing it one way. In the issue of in science, majority does not carry the vote. It's like, what is the correct way scientifically of doing this? And the correct way is to say they are going to be dummy coded. Now, the part of your question was, won't that lead to confusion? Well, no, because each option is a column of its own. So you look at all these options, right? This is the first option, exclude. The first one was sample size. The third one was methods. Each of them is captured in a separate column of its own. And you also have a code book. So if we go back to the code book we discussed earlier, you have the code book here that tells you which of the following changes have you faced when handling missing data. Please select all that apply. The question type is multiple response. And so the code book is telling you that the variable name, x38 whatever, this is the item wording that was used in the original questionnaire. And each of them is dummy coded as 0 for not selected and 1 for selected. So there's no way it can be confused because these are the labels that you created when creating the question. These are the variable names that we have here. And then the dummy options are 0 and 1. Now, from an engineering perspective, when you are building a scientific product, you always want to allow room for error. You also have to assume that these people using this software will make mistakes, right? Coding that 0 and 5, oh, that's a huge way of creating error. If someone mistakenly forgets to code it as dummy code it as 0 and 1 and proceeds to just use the data in analysis. So our philosophy is quite different. And again, this is not to say that Kobo tools or whichever software you refer to is wrong. But in that case, the burden is on you, the user, to make sure that it was finally coded correctly. On the Chisquares platform, we try to build forgiveness into processes so that even if the user has no idea of what they're doing, the data collection is done correctly from the very start so that it's like you can just move ahead and use it. So our target audience is the persona is an individual who has never done research, has no idea what to do things the right or the wrong way, but knowing that they should have peace of mind that the data will be captured correctly and they don't have to do anything special afterwards. So the second part of the question was about, geez, I forgot the second part of the question. Sorry, if you can remind me, I think you can drop in the chat. I can answer that, but I have, for the life of me, I've forgotten it.
Yes. Can I remind you this, please?
Okay.
Yeah. It was about when we do have different questions.
Oh,
and
yes,
the first, yeah,
I remember, yes.
skip logic.
Yes, I
Logic.
remember, yeah. So the sample size, you can't, and that's what we're discussing about when we're talking about the denominator of 1,600 versus 100 at the end of the day. You have to report the analytical denominator. So it doesn't matter whether you have 1 million people in your survey. For this outcome, how many did you have? That is what you have to report because that's what is being analyzed. So report the denominator for that place. And that's why even in the analysis reports, in the Chi-squares, you have different denominators, right? For different aspects of the work, because that acknowledges the fact that different individuals answer differently. All right, next question. Any other questions?
Yes, Abubakar.
Yeah, hello.
Yes.
Can you hear me?
Yeah, we can hear you clearly.
Yeah, thank you, Prof, for the wonderful presentations that you have done. I'm just a student. I have some questions to ask. First question is I would like to know, because this is my first time joining this wonderful class or session. So and it's like I found a light based on the presentations. I learned so many things through this session. So my first question is, I would like to know whether if there is a special package for students, because based on the instruction I can see, the site can be accessible up to the end of April. So I would like to know, because like I said, I was a student, I will start my research after this April. So I would like to know if there is a special package for students and how much are we gonna pay. Is it through a year or 6 months or 3 months? So these first questions. And secondly, based on what I read from different articles, more especially during regarding the methodology or analysis, some of the articles they are mentioning the type of software they use. For instance, they use SPSS version so or starter or something like to express the type of software they use. So based on this site, I would like to know if I can during my research, I can explain or write this chi-square like I said. I use this chi-square site to do the analysis. Is it possible? So this is the questions I have for Prof. Thank you very much.
All right, thanks. Yeah, so you can certainly say you use the Chi-Squares platform for whatever you use it for, and that's fine. And you know, as a student, you're not even the use of software. Just to be very clear and transparent is that you can decide to say I actually did everything manually, and that's also very acceptable. So the focus is not so much on the software from a didactic perspective, as much as do you understand the principles? Is there evidence that this is coherent and that the work done meets the standards? So as a supervisor, I couldn't care less whatever software you use. In fact, if you use no software, that would be ecstatic, right? It shows that you really understand the subject matter. So the bottom line is that the choice of software is less of an issue than you demonstrating a very solid grasp of the subject matter that is being discussed. And as far as pricing, well, the pricing already accounts for students and folks in low and middle income countries, but that's also something we're revising. So we will definitely, when this period ends, we would share that information with all parties.
Okay. Thank you very much. Yeah, thank you. I really appreciate it. Yeah.
All right. Any questions?
Raymond.
Mute. Okay, could you hear me?
Yes.
Hello, you can hear me?
Can hear you clearly, yes.
Okay, thank you very much, Prof. First of all, I want to thank you very much for this excellent presentation. This is my first time getting to even start studying about statistical software packages and things like that. So what I want to ask is, say I have a question here, and a particular question has, for example, 5 options. This Likert scale has 5 options. So how do I enter all these 5 options into the Chi-Square platform?
There are many ways you can do it. You can import the questionnaire. You can choose to, let's say, create a Likert scale. So in this case, let's go with the example you said. So you have a Likert scale you want to create as a single response question. And this is Likert. So you select that. You type your questions here. So your question goes here. I am half by. The question goes here. But I also think that I'm also using a new laptop that is much smaller, so I'm really straining to look at it. And then you provide a label. The label is what later on becomes a variable name. So let's say whatever it is, and if you don't know, you can ask AI to give you a suggestion. So let's say let's type a real question. To what extent do you agree or disagree with the policy XYZ, right? So that's the question we want to ask. So you type a label. Again, the label is what later on becomes a variable name, so that you don't have to start manually. See, when we were using Google Forms, remember that we had to do all this work of typing the variable names after we collected the data. Well, we don't have to do that. We can just type the label, which will later on become the variable name. And if you don't know what to type, you can just ask AI to give you suggestions. AI takes that information, synthesizes it, and then it will suggest that, oh, this has some variable names that you could consider. So in this case, it suggests some things. I can go with the policy, and then the options are here. You can change the options if you don't want. You can say, okay, I want a 4-point scale or I want a 7-point scale. Let's say I want a 7-point Likert scale. And then I want the scale to be in color. So I can say, okay, this is the colored scale that I want and apply it. I can change the color to whatever I want. So let's say I want it to be this dark and this, you can do whatever you want, obviously. And then, but that's how you do it. You can type the response options in, or you can also, import the questions. If you have a Word document or an Excel document, you can also import it. That's how you create the questions.
Okay, any other questions?
I don't think so. I think we've run out of questions.
You are hoping we have. Okay. It looks like it. Otherwise, if you posted your question earlier and we missed it, you can quickly repost it in the next 2 seconds. Faraja, you're back. Faraja can't get enough of you. All right, unmute yourself.
Yes, bro. Thank you once again for this flow. I needed to know whether we can do case management with the Chi-square as we can do it with ComCare. This is for sometimes, once we are looking over, over or after pregnant women, once a woman is getting pregnant, and then she has to follow a vaccination program until she gives birth to her child. So I want to know, because with ComCare, with ComCare we can identify these vulnerable women, and we say that they have to follow this vaccination program and other treatment programs until they give birth to their children. With ComCare, they enter the system, the data collection software, and we follow them. We can mark that they have got the first vaccination, second vaccination, third, until they give birth. Then we remove them from the data collection management. So I want to know whether with ComCare, we can do case management as well, from the start, the entry to the exit of the management system. I want to know whether we can do this with the Chi-square, Professor. Thank you so much. This is very insightful.
Right, sure. So yes, you can do that. The only thing that limits, the data collection is your imagination. You can use a tool for whatever many, limitless number of use cases. It's now you thinking of, okay, oh, this could apply here. So the short answer is, of course, yes, you can. So, and there are many ways you can do that. You can decide to set up a longitudinal study so right now the survey is cross-sectional, where we collect data at one point in time for everybody. But you can decide to say that, okay, I'm going to change this to longitudinal study where I follow people over time, right? So that I can also specify the times where I want to follow them, maybe the first of every month. And so every month I go and that data is collected for that individual. The platform also allows you to also be able to collect data in that longitudinal mode, even in offline settings where there is no internet. Because if you're doing case management, it's also possible that you might be dealing with patients who are in areas where there is no internet. So the platform also supports that, where you can simply go to the settings and go to offline and set the data on offline mode so that you can collect data in areas where there's internet. So let's say you have case managers. You can provide the case managers their name, their email, their phone number, and the location that's supposed to cover. When you provide this information, each of them will get an email to help them set up the survey on their device, or like their phone, which will allow them to collect data even where there is no internet. And then whenever they come back to where there is internet, the data is seamlessly uploaded to the cloud. So yes, in a nutshell, yeah, you can do that. And many more, depending on how you want to set it up.
Evans. Okay. All right, Prof. It looks like we no longer have questions.
All right, awesome. Well, thank you, everyone, and have a great weekend.
Thanks a lot, Prof.
No, thanks.
We appreciate you. Thank you.
All right, cheers.